What is the graph of the function rule? So this will become a problem that you will absolutely be able to do in semester two. You will look at this and if you struggle with it now, you'll look back later and you'll say, wow, I totally know what to do now. Um, and I can give you some real basic tips on this. In fact, the first basic tip that I'm going to give you is to say, let's check the input 0. Now, so what I'm going to do right now, just like kind of referencing the vertical line test, is I'm going to put a vertical line at 0 for all four of these. Okay, whoops, for all four of these. Put it there, put it there. I'm going to put one there, and I'm going to put one there. What we're doing is what I'm saying is, um, if I follow the line, the perfectly vertical line, that's at the x coordinate 0, meaning this is what happens when you plug in 0. Okay, and what do you get out? Well, let's highlight what you get out. Okay, you get out that number right there. Oops. You would get out that number right there. What is that number? We're going to look at it every time. I'm not sure what's going on. Hang on just a second. My pen wasn't marking. But what I'm trying to do is I'm trying to put a yellow dot right there where our line, our vertical line at x equals 0 crosses the curve. And what that's saying is whatever that y value is there is what we should be getting out when we plug 0 into the function. So let's then plug it in. Let's say y equals 3 times 0 minus 2. And 3 times 0 is 0, so 0 minus 2 is negative 2. We should have a y value of negative 2 at that point, or at that place where x equals 0. Where does x equal 0? X equals 0 along the y-axis. If you see me moving along here, x is negative 5, negative 4, negative 3, negative 2, negative 1. X is 0, right there on the y-axis. That's the value of x. Every point along that has an x coordinate of 0. So same thing here, negative 5, negative 4, negative 3, negative 2, negative 1, 0. So what we're doing is we're saying we're checking the input x equals 0 and seeing what comes out. So on this graph, it indicates that what came out, since that's where our line is graphed, that's where our black line that we've got there is at x equals 0. It's at y equals 2. That means that it should be producing, if this one was correct, then we should be producing the number 2 when we plug in 0. But we don't get it. We plug in, we get negative 2. So we know that it can't be A. So we're going to cross A off as an option. Okay? So let's check B. B says, if we went over here to x is 0, and then we followed it up or down until we hit the graphed line, we would see that we hit the graphed line, that black line, at negative 2. It's got a point on that black line of 0, negative 2, meaning if we plugged in 0, we should get out negative 2. And we do, so that's good. So B, so far, that's possible. That might be what it is. Okay, and let's try it for C. If we were moving along here until we got to x equals 0, then we say, okay, we want to find out what this is saying the output value is for the input of 0 for x. And then we follow it up or down until we hit the curve. And we follow it down, we see it's that black line is at negative 2 for 0, 0, negative 2. That fits with what we know. Plug in 0, get negative 2. Also possible. Okay, so C might be good. And let's try it here. If we go over to x is 0, which means anywhere along here, every point along here has an x coordinate of 0. And we follow it up or down until we get to the graphed line, this black graphed line. We follow it up, and we see that it's got, that line is up there at 2 when x is 0, 0, 2. Well, do we get 2 when we plug in 0? No, we don't. We get negative 2. This function produces negative 2 when 0 is plugged in. So this graph can't accurately represent that, or that x value of 2 would have the line down there at negative 2. It doesn't. So We cross this out. Okay. We've eliminated two of the choices, A and D. Now what's the next one? Well, we can do a couple of things. Let's just check a different number. Why don't we just do that? Let's erase 0 and say, what if we plugged in 1? Why don't we try 1? Okay, let's plug in 1. I'm going to use red here. I'm going to say plug in 1, and we get 3 times 1, which is 3 minus 2, and 3 minus 2 is 1. And what that suggests is that if the graph is correct, we should have an x-coordinate of 1, because that's what we plugged in, is 1, so that must be what the x-coordinate is. And we have a y-coordinate of 1, because when we plugged in 1 for x, it produced out 1 as our output value. So we should have 1 comma 1 should be a point on our line. And oops, I don't know what it's doing there. Okay, 1 comma 1. So if that's true, then we should be able to go over to 1 comma 1 on the graphs that remain, and we see our line there. 1 comma 1 right there. Our graphed line is not going through that point, and we know it should be because plugging in 1 for x gets 1 out for y, 1 comma 1. So that can't be C then, because it's not going through a point that we know should be on there. And let's just go check the last one. I'm sorry, whoops, I'm checking B. At 1, I go over to 1, and we go up to 1, and yeah, our line is going through that point. 1 comma 1. We plugged in 1, we got out 1, so 1 comma 1 is a value that should be on the line, and it is right there. So since it goes through 0 comma negative 2, what you get when you plug in 0 is negative 2, and it goes through 1 comma 1, what you get when you plug in 1 is 1, and it must be B. That was the right choice for us. Now, what I was going to say earlier, just to finish this out, is that you'll learn later that this number here, negative 2 in this case, is the place where your line should cross the y-axis. So you should have your line crossing at negative 2. Does not. That's why we crossed it out. This one does cross at negative 2. That's why we kept it. Does cross at negative 2. That's why we kept that one until we eliminated it later. And this one does not, so we had eliminated it right away. So we eliminated that and that one because they do not meet the y-axis at negative 2, which will always be that number when we're in this way. And then the second piece of this that you will learn later is that if this is a positive number, then we're going to be, as we move to the right, our line's going up. So from some points on the line, if we go over to the right, we should be increasing. We increase x, we increase y. That will give us a positive number there. And for this one that we had to eventually eliminate, it doesn't work that way. If we increase x, we'd have to decrease y to get back to the line. And that would not correspond with a positive number for the coefficient there. So for all of those reasons, we are choosing B.